So for that one, a chess problem, the common thing is the distance and the time. Mathematics. The common thing is the distance and the time. So we'll say delta x. First of all, I write this equation. First, I can write delta x. So the x equals x naught plus v naught t plus 8t squared over 2. So the school corner is the origin, and both of them are there. So the x naught is 0. If your starting point with the person you're chasing is the same, then your initial is that very value. But if you are ahead of your friend by a distance, then that will be your initial. So if the person being chased is ahead by some distance, if that one will have an initial. So if there are two people that are racing, one is ahead, then that's the initial. But then these are both at the corner, adepta per corner. The 10 meters per second in the question is just a guide. It just means these people are already butuka. Uyona nikabola na toba malamulo. Before you people have 10 meters per second. Now toba malamulo. Instead of ukula butuka abuino, ule butuka fimbi. So that's the scenario. So the motorist is moving at a constant speed, meaning there's no acceleration. So V naught is 15 meters per second. The only has V naught. A is 0, X naught is 0. So when you make an equation for the motorist, we put 0 plus 15t plus 0t squared over 2. X equals 15t. Abengi base padi wanjipushaga ndamidabo sometimes inoko mufuma because umuntu kusanga ati 0t squared over 2. T squared yakusana 2. When you just multiply anything with 0, the answer is 0. That should always be your reasoning. Not kurachura sana, guys. So multiply fetching to 0. The answer is what? 0. So when you see 0 t squared over 2, then that's 0. Then for the officer, he's starting from rest. He had stopped. Then he starts to chase. So he's also at the corner, so it's 0, that's the origin, plus 0t, he has no initial speed. Okay, the initial speed is always 0. When Gawasangati, someone is starting from rest, then this person has an acceleration, meaning there's a gradual increase in speed. We will not pay 15 meters per second. So x for this one will be 3t squared over 2, which is 1.5t. So I have my equations. You equate them. For these two people to catch each other, you equate the equations. The axes should be identical. That's why I even put them in brackets. So 1.5t squared equals 15t. You equate these two. For them to catch up, these two should be equal. 1.5t squared is equal to 15t. Then 1.5t squared minus 15t equals 0. This one crosses the equal sign. Then I factorize. So when I factorize, the essence is to factorize the common t. So 1.5t, then open brackets t minus 10. So if 1.5 is equal to 0, then t is 0. So when they are chasing each other, they are the time is 0, they are together. Then also after 10 seconds, because when you solve now, t minus 10 is equal to 0. So t equals 10 seconds. So that's the scenario. So when you solve this now, the B is what is the officer's speed at that point. So you just simply say V equals V naught plus 80. The officer is starting from rest, so V is equal to 0 plus 3 times 10. So it's 30 meters per second. What distance has each vehicle traveled at that point? It should be the common distance because Bale Pepekana from the same start. Hello, by Pepeka. So the answer should be the same. But then I use both equations. For this one, you're adding 1.5t squared officer. So it's 1.5 times 10 squared. Yeah, about 150 meters. Then for this one, x is 15t. It's 15 times 10. also 150. It's a bit involving in equation, but when you go through, you understand. When there's a chess problem, you find common equations for distance, then you equate them. Then in those equations, there's a time aspect, because we said time is the independent variable against which a lot of things depend. So then when you equate, you'll be able to find the time. That time will help you to find velocity and the distance or displacement or position. So that's the scenario. So now when we go to the other question, a track covers 40 meters in 8.5 seconds while smoothly slowing down to a final speed of 2.8 meters per second. A finds the original speed, B find the acceleration. Ngamama na hii question ni sana common na tuisolve hapo kale. Ya kukwata displacement, velocity na nani. So we come here. So delta x is 40 meters, t is 8.5 seconds, v is 2.8 meters per second. So now when you are solving this, you say delta x over t equals v naught plus v over 2. A equation, because not quarter delta x, which is this one, t not quarter a is upper, v final velocity. This thing is slowing down, so its initial velocity should be bigger than the final velocity. So you solve in a upper number and solve corner differently. One, we are sending the substitute formula to v naught. If you want, you can cross multiply like normal, but then upper na cancel first na multiply by 2 throughout. Ukuna multiply by 2 na by 2, so these 2 cancels. Then I have 40, 2 times 40 over 8.5. Then it is going to be equal to v naught plus 2.8. Then when you solve this will be 9.4 equals v naught plus 2.8. 9.8 minus 2.8 is 6.6 seconds. The acceleration, guys, will be v minus v naught over t. So it will be 2.8 minus 6.6 over 8.5. The answer will be negative 0.447 meters per second. So that's the way you go about it. So now we want to equation here, delta x over t equals v naught plus v over 2. Tamwale bompya musogo bati kuno ku college kaina ichinja na environment for tamwale bompya. That's what we are using now. The next one, question 7. A racing car reaches a speed of 40 meters per second. At this instant, it begins negative acceleration, meaning Bambo Banyantama brakes and comes to rest in 5 seconds. Naikwatana parachute. Meaning umwela walengesha kwa afurisha kwa nawena to stop it. Determine the acceleration of the car. How far does the car travel after the acceleration? The initial velocity is this. The final velocity is 0. Why? Because it goes to rest in 5 seconds. So now wasanga. Because you have the initial velocity, final velocity, then you also have the time. You find the acceleration. So number 7. Let me go to number 7. So I'll say number 7. It was number 7. A equals v minus v naught over t. So it will be 0 minus 40 over 5. So it will be negative 40 over 5. It's negative 8 meters per second. Then go there for a number to find the time nishan wale for a number next. Next, they are looking for the distance. If you want, you can use the third equation of motion. But then me, I use this very one known as chamimachi. It is sana common traibonfia sana. Delta x over t equals v naught plus v over 2. So you find delta x over 5 equals 40 plus 0 over 2. Delta x, I just cross multiplied there. 2 delta x equals 5 times 40. 5 times 40 is 200. Then you divide 2, it's 100 meters. The other challenging problem is the velocity time graph. Velocity time graph, which I presume you did at grade 12. It's always a must that you do velocity time graph there. So a record of travel along a straight path is as follows. It starts from rest with constant positive acceleration of 3 meters per second squared. So rest ni shiriambira pa 0. 3 meters per second squared for 15 seconds. So meaning there will be a constant acceleration in a positive gradient. In a straight line here, so more axis. So diagonal like. So 15 seconds. Then constant velocity 2 minutes. So 2 minutes, the key is you convert 2 minutes to seconds. Then negative acceleration of 9.5 until it stops. What's the displacement for the complete trip? So that's the way it is. So if final velocity iyalaba panga wasanga final velocity upper first. Look at initial air last when it's decelerating. Okay, when it moves at constant speed to move at that very velocity now for some time, then it will slow down to stop. So the velocity time graph equal to number could draw a trapezium. You have to draw the trapezium. It could say yep. So first part of the motion, v equals v naught plus at. Why are we want to find the final velocity? Yalaba's final velocity, Yalaba 45 throughout until it starts to slow down. So number wasange could plotter, ufido plotter 45 na 15. Then you draw a straight line. Bam. My mother. Then you do a straight line again now, parallel to the y-axis. 120 seconds. So you are supposed to remember that per first part by 15, then per 120. So the total time up to the end of the constant speed is 120 plus 15, which is 135. So ngawasange, you should remember that if final velocity here per first, luka initial kulast, then kulast initial, let's slow down to stop. So that's the reason why we use it now to find the time. We'll say t equals v minus v naught over a. So we'll say 0 minus 45 over negative 9.5. So that's the reasoning there. So t is equal to 4.74 seconds. So kuivika number kaika 4.74 kakushita stop. So you add to 135. So walakwata 139.74. So your A will be 120. Your B will be 139.74. Your height will be 45. You do the same things throughout. So guys, in Gamasovapa, trapezium, what do you get? Area of the trapezium, half A plus B, H. The A ni distance hapa mudu. So nosi kwamba kunshu papa trapezium wekesheni papa di ni isa muri afi murefa kali book kam grade 9 trapezium kala mi pera area of the trapezium ila sangu G9 nosi nasugo yo. So 120 then 139 iwa panshi, then the height of the trapezium. Yes. Ngawasanga there under the velocity time graph is the displacement. So when you solve this, you get 5884.15 meters. If you just say 5844, nishirifye bueno. Shina usanga 5844 shina uchaya. So that's the scenario. Are there any questions?
Me have a question, sir.
Yes, Innocent.
Hello?
Yes.
Yeah, how did you get the final deceleration, which is 4 point something? I'm
The
behind
time.
on that one.
The time, not the deceleration.
Yeah, the
Mwalumbula
time which is 4.
the time ni t equals v minus v naught over.
Oh, 4.74. Oh, yeah.
Must understand what that?
All right, sir.
Yeah. Kai the final,
Well
the initial
understood, yeah.
na muvaka. The final don't drop on a tomb. The
Yes,
initial hapa ni 45 and it's going to rest. And the acceleration now at Perakali question is 9.5. Any other question, guys? That's who's Stephania.
So back to question 5. I'm kindly asking if you can help me understand the thing you said about equating of the equations when the question involves the resting of two people.
Yes, kai they start at the same point. Ngamule pipikana no muntu mami. Mwambira pa mule butuka ma athletics. Mule butuka. If your starting point is the same and your finishing point is the same, what will be common there is your distance. Mfire mwa butuka ntamfu imoyene. Munshita ya para nakai like mole fikira pamo pene pale penalty. Mwa yafuma draw. Mwachambira pamo. Then mwa pepeka mwa butuka wonse mwa wina mwafika pamo. So the time is the same, and also the displacement is the same. So you make equations higher position, meaning you should equate them higher. So you made one here kwa motorist, yaba 15t. Here kwa uyunani, yaba 1.5t. You equate them. And the only way to solve them is either by quadratic formula or by factorization. Is that helpful, my work, Stephania?
Yes, sir.
Mwampa kupano te? Tu no fe, tambule mwampa fiance yo. Patient.
So how about when you use the quadratic formula, then you find out that your values are proven to be negative?
Anishta wamusangire tabamwekete.
All right, sir.
When you chase someone, then must box over equation. Because in a question like, and the question, the way it's phrased is, does the officer catch the motorist? So you find that even the motorist will not be at a constant speed. It may even have an acceleration. Na ina lebutuka so mulepepekana no so nga wasasanga ti value ya time is negative. Nishta wakamweka tepo iyo.
Okay,
Google
sir.
some questions like that. And that's a very wise question you have asked, man. Ile sana ina sometimes. Bushe, uyule pepeka bas, bushara hii kata. Twaleko kuipushe, nasa ipushapo. Na ishide ya suka fene mwene neka mukirasi. Nasa naka. Patience, I saw your mic, you switch off, you switch on your mic. Patience.
So I just needed clarity on the last question. I didn't get it properly.
To plot the velocity time graph.
Yes, sir.
The velocity time graph, you just plot velocity versus time. Velocity this side, time this side. So for the first part of the motion, we are told that for 15 seconds, this person is moving at 3 meters per second squared. So meaning we'll plot this. So what will be the velocity uko? You have to use the first equation of motion, which is v equals v naught plus at. So the initial velocity is 0 because this car starts from rest. So 0 plus 3 times 15. So you get 45. So 45 is what you will plot this side. Then we are told that for the next part of the motion, this person will move at a constant speed for 2 minutes. So the only thing we do is you convert that 2 minutes to seconds by multiplying 2 times 60. So that's why there's 120 on top there. 120. But then at the bottom, we make sure we add this because the time at the bottom is cumulative. If we are at 15, wastako at dia 120, wasafika pale 135. Then I said this is constant 45, constant 45, constant 45 until this person starts to slow down. So this 45 becomes the initial velocity. It slows down to rest. So the rest is 0. So you have to find the time here. So to find that time, you use either in the first equation of motion, you say t equals v, which is the 0, the final velocity, minus the initial, which is 45, over the acceleration, which you've been given in the question as negative. When something is slowing down, it has a negative acceleration. So you get 4.74. So you add up. You add. Then you get 139.74. Guys, mwelantinyo fitu hapa so got. Patience. Mweche. Velocity time gratamane oma. Tuwe mwaya be ipasogo.
Awesa nshachumfa fo mwachilanda.
Ndera namufire mwamo pya nefya bombishe
But
basa
yam
pasogo na nguma madam.
fika no.
Ah.
Navyo fika sana.
All right. Guys, na mwasuka bueno. On our study master, because I think the next thing in case affair mukusanga manani. Where is the classroom? It's here. So on the study master, there's just a mention of Galileo Galilei. Galileo Galilei. He was angry gravity, guys. Galileo Galilei. He died in prison. He was sentenced to hanging by the Pope because he said that the earth was round. Were round, then moving around the sun. Galileo Galilei. So he found gravity that when you throw something, the acceleration is constant and equal to gravity. So meaning when there is no air resistance, in so full, they should land at the same time. An elephant and a leaf, when they drop from the same position, they are dropped from an aeroplane. If there's no air resistance, the elephant and the leaf should reach the ground at the same time. So that's because they have a constant acceleration. The only reason why there's this there's air resistance everywhere in the world. There's friction in the world. So that's the case. So for that gravity, guys, regardless of where you are going, the gravity on Earth is 9.8 meters per second squared. It's rounded off. In some texts, they say 9.82. So if you look around 9.8 meters per second d squared. Common 1.6. Conclude by saying, my equations, the way you will see them on study master, parallel negative. Why? Because gravity is directed towards the center of the Earth. So remember that. Then look up those equations, the alternative equations, like for the height, to sometimes, then also use y minus y naught, just to remind us that it's on the y-axis. So we'll do that. I haven't shared the page, but you will look it up because the most important thing we've done is to look at the questions today. So when we come next time, I want you to read through those notes on Study Master, especially the equations so that to master them. Then I'll come and explain the answers to those two questions I've put there. But then those questions are there for you guys. So imwabene guys nimobonchaile like simwambira di mulubiro lwamwepi kubangira. So enjoy and do. The network has performed, but it has been very tidy bad. We've done 3/4 of the work. There's no need of even meeting another time today. So enjoy your day, guys. Continue to study hard. So mloleke shepo. So free fall can even take ichintu kuposa kumulu. Free fall. Then when something is going up, then it has a positive velocity. When it's coming down, it has a negative velocity. So you should know that. Then when something is above, then its displacement or height is positive. If it's below, then the displacement or the height is negative. So go through those equations, guys. I know we can do this. Yeah. Airtel hotspot taile ikata, then Zamtel as usual it has outperformed. The only time it's ikatika Zamtel is after midnight. Test kwate class after midnight. Na bantu kusiba mikadipira bafyash. Tesho ban. Tesho guys.
Yes, sir.
So that's
Nipati.
good. Yes, ma'am.
Sir,
Yeah.
you're saying you've put some questions on study master, but I've been refreshing since 8 hours. I
Aya free for.
I
Yeah,
can't see
coin.
anything.
Are your friends they've seen? Okay, let me check.
Then
But
I don't know, maybe it's because of the
Clovis. So this is our work for today, guys. The first three, I think we did them the last time. So we'll deal with the remaining questions. So number 4, how long would it take a truck to increase its speed from 10 meters per second to 30 meters per second if it does so with uniform acceleration over a distance of 80 meters? So I think I reminded you last time that when there's just a mention of uniform acceleration, it means you can use the equations, because people get lost when they see the word acceleration like there. Then they'll start thinking maybe the first thing you have to do is find the acceleration. Yes, you can start with finding the acceleration using the third equation of motion. But then I told you that that's one. Now it means you have to do 2 equations. You find the acceleration first, then when you find the acceleration, then you find the time. It's also very easy. But then I would rather just use 1 equation that gives me what I want, because you have the initial velocity there, the final velocity, and the displacement. The distance of, that's displacement. So number 4, if you've checked the answers, they are here. So delta x is 80 meters, v naught is 10 meters per second, v is 30 meters per second, and how long means we're looking for time. That's the equation. That has, if it has the 3 variables that have been given, except just 1 that you're looking for. So delta x over t equals v naught plus v over 2. If you've noted, this equation is not even listed as the equation of motion, but it's the most useful at our level. If you've seen, it's the most useful. Instead of doing 2 equations where you find the accelerations, v squared equals v naught squared plus 2a delta x, then you find the acceleration, then you come to find the time and say t equals v minus v naught over a. Instead of doing that, kusanga fye akenika equation wabika 80 pamulu over t equals 10 plus 30 over 2. 10 plus 30 nakumuta okukiwasanga, it's 40. 10 plus 30. So nga wakwata 80 over t equals 40 over 2. Guys, apango nga walipya sana ensamushu, you can know that palife equals apagaye. You know that these opposites, they can even cancel. So cancel po 40 partial 2 apa more important. Then you cross multiply partial 1. When you cross multiply, t will simply be 4. But apa nimiteekanisha kwati ndefu ndashubukeni, because mwabantu mumula shupa gaye. So you write t over 80 over t equals 40 over 2. Then I flip it. Naipiribula. T, I take the t on top, then the 80 at the bottom, equals the 2 on top, the 40 at the bottom. Then I multiply both sides by 80, so that the 80 cancels this side, because I'm changing the subject of the formula. So your skill in physics is simply just changing the subject of the formula. So number, the answer is 4 seconds. That's all. It's 4 seconds. You can go and try them at home. Number 5. Number 5, okay, number 4 kachinaka. Number 5 I can't sugarcoat. It's a bit involving because it's two-part commotion, a chess problem. A chess problem. Kabolala mambo kumupepeka. Along with some equations kabolala ne ole pepeka. So that there's a lot of reasoning, a lot of analysis. But this one, the ones that I'm giving you are so straightforward because I don't want you kula tondonganya sana ni mtu wa kadipo. No. So a motorist traveling with a constant speed of 15 meters per second passes a school crossing corner where the speed limit is 10 meters per second. Just as the motorist passes the school crossing corner, a police officer on a motorcycle stopped at the corner, stopped there, starts in pursuit with a constant acceleration of 3 meters per second squared. A, how much time elapses before the officer passes the motorist? B, what is the officer's speed at that point?